So this is example C from Rational Expressions, Equations, and Functions, Lesson 5. If you haven't done so already, you should have graphed this function on Desmos to take a look at it and hopefully filled in some of these things. You can fill in everything, obviously, without the graphing function or graphing calculator, and eventually that's what you're going to be required to do. So we have a denominator here that is a quadratic and it is factorable. And remember, I always tell you to factor first. So I'm going to factor that first. And now I can see that the restrictions are 1 and -1. So x cannot be 1 and x cannot be -1. So that means these are both either, one of them is either a vertical asymptote or both of them, or they're a whole. Well, I can't cancel anything out, so I actually have two vertical asymptotes. So x equals 1 is a vertical asymptote. So the graph will approach this but not touch it. And then x equals -1 is the other one. The graph will approach this and not touch it as well. It'll get really close to it as we go higher or lower, but it's not going to touch it. So most likely I'm thinking we're going to have an intercept right there, but we'll see. So the domain would be from -infinity to -1. It would skip over -1. Then it would go from -1 to 1, and then it would skip over 1, and then it would go from 1 to infinity, not including those restrictions. So the vertical asymptote is 1 and -1. The horizontal asymptote I can find by just looking at the degree of the numerator and the denominator. The degree of the numerator here is 1, and the degree of the denominator here is 2. So the numerator is less than the denominator. So the degree of the numerator is less than the denominator. So that means your horizontal asymptote is y equals 0. And that's one of the 3 rules we'll talk about. So here's the equation, y equals 0. So this is a case where the function will cross the horizontal asymptote, and that happens. To find the zeros, we set the function equal to 0, and then we would solve for x. And I'm going to tell you right now, it is 0, 0. That means the y-intercept is 0, 0. So I'm going to plot the 0. I'm going to make a number line down here. This is -1, 0, 1. These are all like my critical values going across the x-axis. And then these are our numbers beyond. So what I could do is I could pick, I know at 0 right here, the value of the function is 0. You go over 0, up 0. I know at 1, it's undefined. It's not happening here and here. But I need to know, is it positive from -1 to 0, or is it negative? So all you do is you put in a number that's somewhere between 0 and -1. You plug it in for x, and you see if the output is positive and negative. And it is indeed positive. So the function from here to here is positive. Then you pick another x value that's between 0 and 1, and you plug it in, and you see what the output is, and it's negative. So that means the function has to look like this. It's going to be positive, it's going to come over, it's going to cross at 0, and then it's going to continue down. Now we need to look to the left of -1. So again, you pick some numbers to the left of -1, x values, and you see what's the sign of the function, and these are all negatives. And I know that rational functions look like this. And then I pick some values to the right, and I find that all the outputs are positive. And it looks something like this. And if you graph it on Desmos to be sure, that's exactly what it looks like. Hopefully you're seeing what these functions are starting to look like. They curve around, they get close to the asymptotes. All right, that is example C. You should try example D. At least try to do the domain, the range, the zeros, the vertical asymptotes. This is going to have a slant asymptote, the next one. And we'll talk about that, the slant asymptote, coming up.